Hi, this is Margot. This is Saturday, July 7th, 2018. And what we're looking at here is climatereanalyzer.org, and this is from July 7th, today, Saturday, and this is the sea ice and snow cover for the world. And what we're looking at, this is the Arctic, and this is the first we've seen of a big hole developing in the Arctic sea ice. I was stunned when I saw this. I had not looked at this in a couple of days, and it's amazing how fast things change. And I have a picture from 2 days ago when I did the sea ice video, and you can see from this picture and this was from July the 5th, there was not a hole there. There was definitely not a hole there. And then here we are on July the 7th. And look at the difference. Besides the hole, the thinning of the sea ice is much more on the edges, and it's melting so fast and so dramatically. And I had to do a video. I could not do a video. So this is my ClimateCast update since my last one. But we're starting with looking at Arctic sea ice. And let's go here. Well, first of all, I'd like to thank a couple of people. I'd like to thank Robert Westenra, I think that's how you say the name, person linked my video in the blog post from Seymour Rocks, and I appreciate the credit there. And thank you, Sandy Shellis, for posting my videos on your Facebook page on Environmental Coffee House and mentioning me in your videos. And I am a moderator for the Abrupt Climate Change group on Facebook, and I kind of keep a low key and just kind of new on the climate scene as far as bringing data forward. I've been interested for a long time, and then of course I had my second interview with Guy McPherson at the end of May. I've been following abrupt climate change for about, I'd say, a year and a half now, but the way I got into it was I am empathic, and I'm empathic a lot with Mother Earth, and as a result, that's what's got me so into keeping up with what's going on, because I do empath and communicate with the soul of the earth. And so I just come at it from a different angle. I'm not a climate scientist, but I am a hypnotist, holistic life coach, empathic spiritual healer. I've been on I've investigated UFOs and paranormal and metaphysical, and I do a lot of meditation. I do a lot of inner work, communicating with other realms, and so I come from a whole different angle. I'm not a scientist, but I have a scientific mind, and I'm a musician as well. So that's just a little background on me, and so I, thank you for the people who are welcoming me into the Abrupt Climate Change community. I really appreciate it. And we all have different pieces of the puzzle, and we're all doing different parts of work here, but we're all working as a team to bring to you, our audience, the most up-to-date information that we can, and bringing the truth, because we have to know the truth, and it's been covered up for way too long. And when we see a big hole in the Arctic sea ice, and no one from the climate science world is reporting on that, there's a problem. we got a problem, Houston. So we're gonna go. Remember this website that I showed you guys in my last video? Now, they did not have data on from July the 5th because I looked yesterday. They're a day late. This is the National Snow and Ice Data Center, and this is satellite imagery from the military. So, and they're going to be testing from July 9th through the 12th, so we might not have any images during that time. And I said in my video that would be a really good time for us to have something blow up in the Arctic, because then they wouldn't have any images of it, or they could just scrub those and we wouldn't see. So I just find it curious that I did that video and then 2 days later we get this hole in the Arctic sea ice. And now here's July 6th. They didn't have data from July 5th because I looked. July 6th is from yesterday. There is no hole here. Of course, they're a day after this Climate Reanalyzer. So we'll look tomorrow. Everybody needs to look tomorrow and see if the data from July 7th with the satellite imagery shows this big hole that we're seeing on Climate Reanalyzer, because it's not showing here. So I just thought I'd show that. So now let's do our climate cast. Now that I've gotten everyone's attention, we'll go ahead and do this part first and look around the world at the sea ice and snow cover. You can see that it's melting more on the northern part of Russia. The sea ice is a lot thinner to the east of Novaya Zemlya. It's melted all the way around that little island. It's melted all around England, Greenland. It's melted even more. It's melted more in the Hudson Bay. And thank you, YouTube subscribers, for correcting me if I don't have my geology places exactly right. I'm learning too as we go along, so thank you for correcting me. I'm happy to be corrected. You can see that there's more blue ocean here where this East Siberian ice shelf is, that goes all the way across this northern part of Siberia, and there's blue water along the coast here and here and here and here as well. And we've had wildfires burning in Siberia up here in this area. They have had very high heat. They've had massive wildfires. There are articles out there. I don't have time to pull them up and read them for you guys, but they've been posted on Facebook and different places. And when we go to CAMS, I'm going to show you the surface level ozone and the surface level methane is off the charts in this whole area, and so it's created this toxic smoke that's so hot and coming out, and then the jet stream has taken this smoke, and you can see how the jet stream has come right up over this area and pulled it right over the Arctic. And so that smoke is hot, it's full of sulfuric acid, it's full of all these particulates, and as it's coming over the Arctic Ocean, it's heating up that ice even faster. And I'm thinking that's why we had that hole develop in the last 2 days. So, and you can see precipitation there, and we did have some rain. There's been some rain up here in this area. We've got a little bit of rain here, a little bit of rain here, and whenever it's raining, it melts all the ice that much faster. And also the temperature anomaly chart, you can see this whole area is a lot hotter than it should be, than it normally is this time of year. So this is very, very, very disturbing, and we're setting record heat waves, records. There have been hot weather records set all around the world. This is only July the 7th. We're only a couple of weeks into summer. We're having weather that we should be having at the end of July and into August. And you can see it's so much hotter, and we've got droughts, and we've got wildfires going through Colorado. We've got them going through California. I live in northern Nevada, and there have been wildfires all around us here. We had some weather days this week where I had to keep the windows closed in my apartment and the air conditioner going because I am in the sensitive category with a lot of allergies. And we'll go ahead and show the sea ice or the ice sheets in the Arctic while we're here. I mean Antarctic. And this looks pretty good, but if you look on this website, the concentration is shocking for the Antarctic, and that was what Robin talked about in the article, how the concentration seems like, with it being the middle of winter, it should be more concentrated. We shouldn't be seeing all these blues, because when you have that lower concentration, that's where you're going to have, like in the Arctic, you have that lower concentration. Then when you have something like that jet stream coming up with all that toxic air from all the wildfires and everything, it's gonna make that sea ice it just melt so fast. And so it sets up what happens is, when you've got the methane, and when you've got the methane, and here's global methane, this is surface level, and they've not updated their data since the 4th. So we can see actual data here through the 4th. This is for methane. They update their data on everything else so quickly on CAMS, but on methane they're usually 2 or 3 days behind. I don't know why that is, but it is what it is. But when you see methane coming up over here, and you'll see it when we run this movie, and you're going to see sulfur dioxide, you're going to see surface ozone, and when you see all of that mixed in together, that creates a toxic soup, and it creates self-reinforcing feedback loops, because all the methane heats up the atmosphere, and so with the hotter atmosphere, then you know, it's going to heat up the ground more, and more methane is going to be released from the permafrost, and more carbon dioxide is made, and the whole 9 yards. So it's a whole self-reinforcing feedback loop. And so what we see is the East Coast. We'll just start over here in North America. The East Coast of the United States is looking, well, we still have it coming off the East Coast here. And remember, we don't have actual data after the 4th, so this is forecast. So we'll have to wait for actual data to come in. But methane actually looks better over the United States than it has. We still have a lot over in Brazil and northern South America. We do not have methane being released out of the Antarctic, contrary to what somebody was trying to say. We have methane being released in Alaska, where there's melting permafrost there. And methane, for those of you who are not familiar with this, the green, like this chartreuse green, is about 1900. This yellowy is 1920. These readings are high. The lowest, even the lowest readings worldwide are high. For us to be in a balance situation, it should be reading no more than 1250 parts per billion, and you won't find a reading like that anywhere on the globe. Not at surface level. You won't find that anywhere. The lowest you'll find is like this blue-green color, which is about 1800. And methane has skyrocketed since the industrial revolution. I've done a lot of methane videos. The first one I did was on August the 28th, and I do a whole background on methane and where it comes from and different sources and why it's bad and all that stuff. So go back and watch some of my earlier videos. So when we get into these red levels and the dark red, this is very dangerous because it's heating up the atmosphere that much more. So like this brick red is like 2040 parts per billion. That's brick red. And then the black red is 75,600 parts per billion. So then we're looking over England. It's over England and Wales and Scotland. It's not as bad as it was over the ocean there, or I was seeing it coming out of the ocean there. It's actually Norway, and this whole area is looking better, but is still so it's more south instead of right on the coast. But see, it's popping up in the ocean, and then Europe and like Russia, and then Siberia. This whole area, it's got methane coming up. And then in the Arctic Ocean, whenever you see it coming up in the Arctic Ocean, that's bad news. That's bad news because that's methane coming up from the sea floor, from the sediment that's heating up, and the permafrost that's melting, because there's frozen permafrost in those sediments too, and then methane is coming up. So, and then we've got it. This is this area here in Saudi Arabia, and here in India, China, in East Asia, wherever you have heavily populated areas, you're going to have methane produced because it's a product of industrial civilization. And civilization is a heat engine, like Guy McPherson says. Now, Australia looks pretty good. Of course, they're in their winter period. You see mainly methane coming up around the on the right side, on the east side, and methane can be produced or is produced in oil drilling operations and fracking and things like that. So there's our global methane. Methane can also be one of the toxic gases that comes out from volcanoes. And we've had a lot of volcano activity. Methane, carbon dioxide, and ozone, those can be produced, and sulfur dioxide from volcanic and geologic activity. Okay, so let's look at sulfur dioxide next. Now this data goes back to the 3rd, and it's updated through, let's see, I think it's through today for sulfur dioxide. Yeah, it's through today. And so this is actual data that we have through today for sulfur dioxide, and then it will go into a forecast period. So you can, let's run this movie. Right off the bat, what I'm seeing worldwide is this base level of sulfur dioxide of this olive green of 0.5 parts per million to this lighter olive green of 1 parts per million. And then a lot of areas are in the cream colored 3 parts per million, and then the gold is 5 and 10, and then parts are in the red zone, and that's where you have volcanic activity going on. And that's going, we still have eruptions going on from Hawaii. Now we're into the forecast period, so you're going to see it kind of thinning out. We have an ongoing volcanic activity in southern Mexico. The Galapagos Islands have been erupting. We've got stuff going on off. See, that was the Galapagos when that was going off. In Indonesia, you saw that stuff happening. In southern Africa, we have leftover stuff in Brazil. We've seen some really interesting activity, sulfur dioxide activity in Brazil in the last couple of months. Also in the Antarctic, if you'll look, I have to hold the picture with my cursor. If you look at where it goes into the cream colored zone there, down near the Antarctic, I'm sorry, I keep saying Arctic. There is an active volcano down there, Mount Erebus. It's not really blowing up, but it's an active volcano, and it is releasing sulfur dioxide. Sulfur dioxide that's released into the atmosphere will break down into several components and will turn into sulfuric acid and a whole bunch of other stuff, and it actually breaks down the good ozone, the ozone layer. And we can see that Australia has the green colors through most of it. It gets leftover sulfur dioxide coming off of Indonesia, and this is a highly active geologic region, this whole area from Indonesia all along here. And so you're going to see higher sulfur dioxide levels down there. And okay, let's start this over and let's look up here at northern Siberia. There is sulfur dioxide. Did you see that? Where it popped up? That's where those fires are. And where you have the wildfires like they've been having, it does create sulfur dioxide. That's one of the byproducts of those wildfires. It's spooling here. It's got to catch up with this view. Here we go. Now let's watch. See? That's those wildfires. But you're going to be shocked when you see the ozone over there. The bad ozone. Okay. Now we're running into the forecast period there. So I'm going to stop sulfur dioxide. Now we're going to look at ozone. First we'll look at total column. Now this is the good ozone. Good ozone is measured in total column. And this blue is 225 DU. That's Dobson units. And right now we have the ozone thinning at the South Pole or the Antarctic during the winter because the ozone decreases in cold weather. And then when it becomes winter in the northern hemisphere, we'll have a thinning of the ozone over the Arctic. But what's curious is we have thinning of the ozone around the center of the Earth and also around northern hemisphere as well and southern hemisphere, all around these areas. So let's run this movie, and the ozone data they're current, up to date today. So we can see now where it's thin and even like in these green and even up to 300 DUs, it's still pretty thin, and you can get severe sunburns because the ultraviolet radiation is coming through. The ozone, good ozone, filters out the UV radiations from the sun, but we have such thin and spotty ozone all around the planet that you can get this bad UV radiation coming through. And I did a whole ozone series of 3 videos. If you haven't seen that, go back and watch that, and you'll get a crash course on ozone, what it is, and good ozone and bad ozone, and why we need to know about it. So I'm waiting for this movie to start. Okay, not sure why this movie isn't starting. Maybe I need to reload this page. Okay, here it goes. Now you can see it's really thin over Ecuador and Peru, parts of South America, and it's very thin all around the equator, and here's Indonesia, and all of these islands where people like to go and vacation. And you can see that Australia, especially the northern part of Australia, has quite thin ozone. There are record numbers of skin cancer in Australia. They're thinking because of the UV rays that come through because of the thin ozone layers. But really, it's worldwide. It's worldwide, and you can see here in the United States, like this, even this green here is only 275 Dobson units, and that's through a lot of this northern hemisphere. Look, Africa, look, a lot of Europe and Russia and Saudi Arabia and Iran and Pakistan and India and China. A lot of areas have very thin ozone. Look in the Arctic even. They've got thin ozone up there. So this sulfur dioxide, or sulfur dioxide that's really been gathering in the atmosphere from all this volcanic activity is taking a toll on our ozone, and is just chewing it up. Just chewing it up. So there's that. Now I'm going to switch to surface ozone. Now the reason this is important is there's good ozone and bad ozone, and I talked about it in my ozone series. The bad ozone is created at surface level when sunlight interacts with pollutants in the atmosphere. And when this happens, it creates ozone that's at the surface that's close to the earth, and it's very harmful to the health. Very harmful. And it can create all kinds of breathing problems, respiratory problems, heart problems. I mean, it can send you to the hospital. Now what we're looking at, this is global surface level ozone. This is in parts per billion, and the Environmental Protection Agency says that anything over 70 parts per billion, which is this cream colored, people shouldn't be breathing that for 8 hours. Anything over 8 hours at 70 parts per billion, that was in a work situation, is dangerous for the average person. Of course, for the sensitive person like me, there's no way I could be around 70 parts per billion. So even this olive green is 60 parts per billion, and you're going to be shocked when I run this movie and you'll see that these are high readings. And then we're gonna look up here at Siberia, and it's how it just covers it in the red, and that's like 120 to 150 parts per billion, and that's like twice or over twice what's the safe level is. And you're going to see it, that's from the wildfires. You're going to see it popping up over here in the United States from the wildfires. In California, you're going to see it in Colorado. So let's run this movie. This is actual data. Here it goes. I'll just let it run through couple of cycles. But it's really awful up here in Russia. It is. That's where all those wildfires are. And this is, bad ozone is created as a result, is part of wildfires too. So I'll move it around so people can see all their countries that they're living in. Australia looks good for ozone. South America looks pretty good. Most of Africa, the lower half of Africa, most of that looks pretty good. Now we're into the forecast period. Let's start it over. Okay. It's got to load up. Here we go. Now, this bad ozone goes away at night because it's created as a result of sunlight, and then it comes back in the daytime. So that's why it's green on half the planet where the bad ozone's being created, where the sunlight is, and then it switches to the other side where it goes to daytime on that side, and then it's nighttime over here. So let's zoom in. Let's look at the US first of all. Let's zoom in. Ozone, surface level ozone, can also be a clue of geologic activity, like volcanic activity that's going to happen. So when you see sulfur dioxide and ozone in an area, then but there's no wildfires, I'm thinking, and there's not a whole bunch of civilization to make that stuff, then that could be geologic, and it could be volcanic, something that's about to erupt or come up or emit or something. Oh, look down here. Did you see that? Down here in Baja? I had not seen that before. Let's go a little closer. I really love doing these videos because, you know, we're exploring this stuff together. Let's go back. I mean, if it weren't so close to the end, you know, I love science. I love studying this stuff. I think it's fascinating. Look at all this green over here in the Atlantic Ocean, and green over here. I talked about that before too. Here are those wildfires in Northern California. Okay, here we go. Get ready. Get ready. Ooh, that happened, and that happened when Colorado. You saw that? Here's Colorado. Here's Utah. There's wildfires there. This is still actual data. Ooh, did you see that? I'm going to stop. Look. I don't know if there's fires going down here. I'm assuming there are. Down here on the Baja Peninsula. I don't know. That was from July the 6th. So that was from, but this is UTC time. So that might have been a couple of days ago actually. So if any of my viewers know about that, you can leave that in the comments section. So this is data. We're still in actual data. I'm just clicking forward. Each click is 3 hours. So you can see it coming back. as it's daytime in the United States. Yeah, see, look at that. Okay, now I'm going to rewind. Now we're getting into the forecast period. So I'm going to rewind it, and now let's look at Russia and Siberia, and let's really look at this and think about all the toxic air, massive toxic air that's being created and how it's being carried up over the Arctic Ocean, and that hole popped up, and it's easy to see how that hole popped up right where it did. It's easy to understand that now. Let's go back. Let's get that. See? That hole. I want to go to that view. There it is. You see that? And now let's look at ozone. Okay, so it's right up here. It was about up here that the sea ice hole has been created. Okay, now let's run this. So we're back at the beginning of this time frame from July 3rd. Okay, you can see it moving. You see it's getting bigger each day. Now remember, this is surface ozone. See how much bigger it got there with the wildfires? Oh, there was something over there, on way over here on the right. Watch. Okay, now we're into the forecast period. So they're forecasting, well, we'll run that. They're forecasting from the data that was already inputted. They're forecasting that more will be happening because of the data that's been put into the database. And the wildfires have not been put out. So we're going to have to watch this very, very closely. We'll be watching this very closely in the next few days. And like I said in my last video, if I saw anything unusual or freaky, or if I had a bad feeling, that I would do a video before I normally would. And so that's why I'm doing this video now, because I saw this and I saw the hole in the Arctic Sea, in the Arctic ice. So there's that. Now, to round it out, we'll do carbon dioxide. Just to round out our report for this week, we're going to look at global carbon dioxide levels. This defaults to total column, and this is parts per million. And you can see that it goes from green up through the scale, through yellow and gold and red. So this is from low to high, and the lowest that we see anywhere is a dark green. Actually, there's some blue area up here, but won't be for long. The majority of the planet is over 410 parts per million. So let's run this movie. I'm sure they have their data in. Let's see. Carbon dioxide. I'm sure that's up to date. Nope. Their latest data is through the 5th. So I don't know why this isn't current like the others. Anyway, so as of July 5th, so after the July 5th, it'll be going into the forecast period. So we're going to run this movie. And we can see that the worst area is from about the equator up to through the United States and up into Canada and across that same latitude going across the world. Northern Africa, Saudi Arabia, India, China, Asia. Those are the worst areas. Now this is bad down here in South America. That's part of the Amazon rainforest. And I'll just move the map around so everybody can see their country. Australia looks pretty good for carbon dioxide emissions. You look good, Australia. Now this is total column. United States doesn't look good. Now, of course, carbon dioxide is also created with wildfires and industrial pollution and cars and things like that. Carbon dioxide is mainly created because of industry, mainly with these high levels in the atmosphere. And see India burning, when you burn coal, things like that, burn a lot of gas, make carbon dioxide, etc. Most people know more about carbon dioxide than these other greenhouse gases. Now, if you want to look at it at surface level, this gives us a better idea about what you're really like breathing in. And now at surface level, you've got like this green color is 410 parts per million, and then it goes on up. Like getting into the yellows, that's about 420 parts per million. And then when it gets up into the orangey and the red-orange, that's 428. Then you're getting into red, and like this dark red and brick red, like that's 434 and up. And I can't even read that because the numbers are overlapping. So at surface level, it's much worse than at column level. But this stays in the atmosphere for a very long time, over 100 years. It doesn't go away, and this is what climate scientists were first, up in arms about, and this is why people are so much more familiar with carbon dioxide and its effects. And it helps heat up the atmosphere and creates this toxic soup of all this stuff. And you can see that most of the United States is in the daytime. This is measured in the daytime. It doesn't go away, but it's measured in the daytime. And because their sensors have to have sunlight. That's one thing I read. A lot of the United States is in these way, way, way high levels, up to probably 450 parts per million or higher. Look at South America. That's disturbing. Australia looks good. You've got a little bit around the edges. Indonesia and that area down there doesn't look too good. Africa, let's start it over. Africa has a lot around this midsection where the equator is, where it's so hot. Europe gets into the danger zone. I mean, this almost looks like methane. If I didn't know better, I'd think I was looking at methane from this chart. But this is carbon dioxide at surface level. See? It's even up here. And this is where those wildfires are burning. And then, as you go up in the atmosphere, you can change the chart here, like at 850 HPA, which is the next reading up. As you go up in the atmosphere, it's even worse. It's this awful, awful toxic soup. Like this dark, I don't even know what that's supposed to mean, because that chart doesn't make any sense. This is 409 parts per million on the red, and then that looks like 1460.5. I don't know. But it looks like the apocalypse to me. It just doesn't look good at all. And look how it's gathered over the Arctic. These dark, high readings. And not over the Antarctic. Probably because it's cooler down there. They're having winter down there. But over the Arctic, it's gathered where it's hot. So that's very disturbing. So if you wonder why you can't breathe, you add up all of these greenhouse gases and this toxic soup, and you can't leave out nuclear radiation and pollution. Can't leave that out. A lot of climate scientists do. In fact, I don't know of any climate scientists who include it. I don't know of any of them. This is at 50 HPA. This is going higher in the atmosphere. That's even worse. This black is 459. So if you wonder why you're sick, and you don't feel good, and you have brain fog, and you can't breathe, and you hurt all over, this could be why. And this is at 300 HPA. So, I just wanted to show this hole in the sea ice once more. I didn't expect to see a hole there. I really didn't. I expected it to kind of like melt more around the edges, and then, we'd see it like shrinking in a little bit here, a little bit there. I just did not expect to see that huge gaping hole right there. And that East Siberia ice shelf runs all across here, and that's where they're expecting the methane bomb to be released just any time now. There's so much stored methane up there. So, I think time is short. My name is Margot, and I'm signing off until next time. My website is margoshealingcorner.com, and I suggest everyone get your spiritual house in order. Time is short. God bless. Go in peace. Goodbye.